Ladies and gentlemen, please welcome to the stage Chief Technology Officer at Decoded, Amadeus Stevenson.
I've gotta break through.
Good morning. Hi, everyone. I look a little bit different. It's lovely to be here. I have the pleasure of working with Catherine and the team. Hands up, who was here last year? Hands up, we did a little virtual reality experiment. Do you remember that one? A few hands? Okay. So we're going to be interactive today as well. And what I'm going to kind of really demystify is one of the things that we've been hearing a lot about today. So Woz talked about it, Amy talked about it, Catherine talked about it, and it's this idea of artificial intelligence. Now, actually, I don't like this word artificial. I think it's confusing. What I'm going to start with is a question. What is intelligence? If you can't define intelligence, how on earth are we going to define artificial intelligence? Does anyone actually think they have a really clear understanding of intelligence? Okay, bit of a mystery. We're going to play a game. This one is called Hands Up if you think the person I'm going to show you is intelligent. Is everyone ready? So again, if you think they're intelligent, raise your hand. Okay, bit of a classic, Albert Einstein, very book smart, super intelligent. All right, next one. David Beckham. Come on, he's a super smart guy. He might not be book smart, but he's foot smart. See what he did there? Foot smart. Highly intelligent athlete. Okay, let's try a different one. That is Lady Gaga, in case you're wondering who that is. Super intelligent songwriter, musician, activist, creator, highly intelligent. Again, Frida, incredibly intelligent artist, poet, painter. Last one's a bit controversial. Kim? Anyone? Super business smart. I mean, come on, she's like a multi-millionairess, and she's done amazingly well in life. So the point of that warm-up is these people are all intelligent in different ways. Intelligence isn't this one single thing that computers can do. And I think it's really important to challenge what we mean by intelligence. And when scientists try and study intelligence, they actually study squirrels. This is a squirrel. Hands up who thinks the squirrel's intelligent. That's pretty intelligent. And scientists have studied squirrels for many years, and a couple of years ago, they asked the question, is a squirrel smarter than a fifth grader, so a 10-year-old child? Squirrel versus 10-year-old. Hands up if you think the squirrel is smarter than a 10-year-old. A couple of people, okay. Hands up if you think a 10-year-old is smarter than a squirrel. Okay, well, you're wrong, because squirrels are way smarter, at least in a very specific way. What the scientists did a couple of years back is they took about 10-year-old children, and they gave them 15 little nuts, like plastic nuts. And they said, go into this park and hide these nuts in different places. Come back, wait 15 minutes, and then go back out and collect the nuts that you've hidden. And by the way, you can steal other children's nuts, because that's what squirrels do. They were terrible. Kids couldn't remember, they forgot really quickly. But a squirrel can hide 10,000 nuts a year, right? And they can move them from place to place up to 5 times. They're incredibly intelligent at hiding nuts, right? And I think we all know that, of course, a human's smarter than a squirrel, because as a 10-year-old grows, they learn. They learn, they become sort of intelligent in different ways, they practice, they become craftsmen. And it's this idea of learning that really is at the heart of artificial intelligence, which I'm trying not to say if I can help it. And we kind of heard this a little bit before, but this is the idea of machine learning. So what if we could teach a machine to learn, and therefore exhibit some sort of intelligence, more than you can just program? This was the game, that's Lee Sedol on the right, and he's just losing to a computer for the first time in history at this complicated board game. So this was a watershed moment in the history of machines, because the machine wasn't told exactly how to play, it kind of learned along the way. So machine learning is this kind of huge buzzword, which I'm going to break down for you in 3 ways. So this is an educational talk with a bit of interaction, and I'm just going to go into the 3 different types of machine learning. I know it's before lunch, and you're like, okay, hope everyone's ready for some learning. So the first type of machine learning is called supervised machine learning. Hands up if you've heard of this, supervised machine learning. Right, this is the most common type of machine learning. It's been around for decades. the fraud detection systems MasterCard has are based on supervised machine learning, and it essentially is exactly what it says. It is a human supervising a machine to learn. I literally just said supervised machine learning. And what that means is a human has to first say, OK, here are 10 million transactions that are not fraudulent. Here are 10 million that are fraudulent. Go away, kind of learn or like embody that. Now I'm going to give you 1 million new transactions you've never seen before. Are they fraudulent or not? That's supervised machine learning. Now, this has been applied in many different areas. It's, again, very common. To show you one example, this is a really fun game called Quick Draw. I'm going to make sure my sound is up for this one. This is a team at Google decided to teach their machine to recognize a doodle or like a drawing. And what we're going to do now is we're going to play a game where we're going to be given an object, and it's going to try and guess what that object is. And again, it is learned from other humans. So let's try. Draw a blueberry. OK.
I see circle or hula hoop. Oh, I know. It's blueberry.
OK, so got that one. Let me zoom in a touch. Draw a bat.
I see ear or heart or tooth. I see butterfly.
Is that a bat?
I have no clue what you're drawing.
Oh, great. Thanks, Google. You're meant to be like the smartest thing in the world. All right, I'm going to go to the next one. So there's only like a few more. Lightning. OK, this is easy. Draw lightning.
Oh, I know. It's lightning.
That was pretty fast. I didn't even finish it. All right, draw a purse. Oof, OK. So
I see necklace or moon or circle or pillow or potato. I see blueberry.
Oh, come on. Now that's a blueberry? I'm not making this up. I'm going to have to skip that one. OK, let's try. We've got two more. A toothbrush. OK, quickly. Toothbrush.
I see line or leg or nail or broom or street light or cooler. Oh, I know. It's toothbrush.
Right. OK, the last one. Draw a stethoscope. I'm getting all the hard ones today. OK. I've watched
I see
Grey's
necklace
Anatomy.
or nose or garden
so I think
hose.
that bit goes in the ears, and then I think there's a bit here.
Oh, I know.
There we
It's
go. I didn't even
stethoscope.
finish drawing it. So that's pretty fun. Thank you. I'm a great artist, obviously. And what's interesting is they first had to teach it what it was. So if we take one that I got right, let's take the stethoscope. It thought it was maybe like a nose or a balloon. That was its other guesses. But this is the actual input data. So these were the sketches which they gave it to teach it to understand what a stethoscope is. Okay? So that is supervised machine learning. It's used all over images. It's the most common type. The next type of machine learning is unsupervised. So rather than a human telling a machine some examples, it's like, here's a bunch of data. Can you see any patterns? So this is a very useful type of machine learning for what's called clustering or finding groups. And the example I have is quite a fun one. It's a story about love. This is Chris McKinley, and I think similar to Amy mentioned something like this. He was a mathematician who was finding it hard to find, a date. So he was on OkCupid. Has anyone used OkCupid before? Safe space. I mean, there are lots of cameras, but OK, well, there's a bit of background. The most important thing to know about OkCupid is when you create a profile, you have to answer 300 questions out of a list of 10,000. Things like, what's your favorite movie, French or Italian food, dog or cat. And then you assign a weight, saying, I don't care about dogs or cats, but I really care about French or Italian food. So he was like, OK, can I somehow extract every woman in OkCupid's preferences? Then I can kind of game the system. And he was like a poker player as well. So he wrote some scripts, some little robots to go and randomly answer questions, check other women's profiles, pull the data down. Then he got blocked, because they were like, well, somebody's clearly trying to hack the system. So then he asked his friend Sam, who used OkCupid, hey, Sam, can I actually record you as you use OkCupid? And he watched how a human would use OkCupid. Then he copied everything from how quick they typed, how slow they clicked, and he built that into his little bots. He was able to pull out all that data, and all he said to the machine is, go and find similarities. It found 7 similarities, 7 groups. Now, initially, he didn't know what these groups were. The whole point of unsupervised machine learning is there's no understanding of what you're looking at. So he had to go on dates with people from each group. And he noticed some very striking sort of patterns. So these are the 7 groups he found. And he labeled them. So green were first-time dating people. We had Samantha, were slightly older women with adventurous tastes, like Samantha in Sex and the City. Dog were people who loved animals. Tattoo, he found one of these groups, just everyone had a tattoo. Mindful, people into yoga. Diverse, and then gods, these were religious sort of people. So again, the machine didn't know who these people were, it just saw a pattern. A human had to then come later and assign meaning to it. But this is an example of throwing a huge amount of data to a machine and telling it to find a pattern. He ended up choosing diverse, which were like artists. He went on 88 dates. And on the 88th date, he was very honest and said, I've hacked the system to find you. And it turned out his partner was into that. They dated for a couple of months, they got married. So it's kind of a happy story. Slightly creepy, a little creepy. But this is the idea of unsupervised machine learning. The final category is reinforcement learning. And this is what, if you kind of talk to data scientists, they get really excited about. This is the idea of, can you essentially set a computer program, an algorithm, a goal, and you don't tell it how to get there, you just let it play itself millions and millions of times. This is what AlphaGo did. This is what sort of a lot of different things are doing. Can it figure out by itself, which is not an intelligent task, it's a repetition task, what the best technique is? So there are two examples. This is actually the original research that came out from DeepMind, which was Google's reinforcement learning lab. And they tried to solve the problem of how do you play Woz's great game, Breakout? So all they told the machine is you can move left or right, and you need to maximize your score. That's all they said. So initially, it's really bad playing. Can I say, like, misses the ball? It's like pretty dumb. Sometimes it scores, sometimes it doesn't. Pretty terrible algorithm. What they then do is say, OK, now 2 hours of training. So play the game for 2 hours, incredibly fast, because it's a fast machine, and it gets better. So now it doesn't really miss the ball. It actually plays pretty decent. It's pretty good. But then they ask the question, OK, we've got the machine to play Breakout pretty well. Can we get it to uncover a superhuman technique? Or is there another way you could play that we just haven't figured out? So this took 4 hours, and then the magic happened. What the algorithm discovered, again by trial and error, is that actually, if you always hit one side of Breakout, you will eventually get the ball up the top, and you can get loads of points. Right? So again, all it's been told is play again and again and again until you do a great job. This is the idea of reinforcement learning. So it's kind of great, it's exciting for data scientists because you don't know what it's going to come up with. This is where some of the ethics become interesting. A great example of this is how do you actually teach a machine how to walk? So again, this is a short clip. Again, many, many hours of walking and failing. Oh. Again, you kind of get the idea. You're just, now that machines are fast, you can just tell them to keep running simulations again and again and again. Robot spiders, this is fascinating. It doesn't really look like a human, but it does the job. This one in particular, was a technique of like crab walking, which worked. Again, not very human. So that's reinforcement learning, kind of a bit of a dark art to some, really interesting. And I do think there's a lot to say about ethics and robots. 2 weeks ago, I don't know if anyone's seen this. This is Boston Dynamics. This is not a AI robot. This is just a robot which is being taught how to operate. But it's pretty amazing. This is all robot. Hooray. Pretty terrifying, I find, personally. Yeah. So we are kind of getting towards that singularity of the hardware, which can self-balance in a way we've never seen before, plus the kind of machine learning algorithms to get it to learn. So this is happening. It is absolutely happening. It's not going anywhere. But, with all of this theory, you might think, OK, why do I care? Why do I care? Let's quickly think about the payments industry. When you think about commerce, you think about, in the old days, you'd go to a store, you'd talk to someone using your voice, and you'd buy something probably with cash. Then along came the mailing catalog. People remember getting like a catalog in the mail. I get like a Sears catalog. My mum used to get one back in England. She'd get very excited, and you'd fill in what you want to buy, send a check, off it goes. Then the television networks came along. You had like QVC, TV shopping. Pick up the phone, enter your MasterCard details in, off it goes. Then, of course, the internet came, the World Wide Web. You could go on Amazon.com, buy stuff you're now typing and clicking. And, of course, mobile came as well. So now you're tapping, you're sliding, you're swiping. So all of these different technologies have impacted the way that we interact with things. And you've seen it a lot today. I guess this maybe is a mini theme. But Google Express recently partnered with Walmart, Target, Home Depot, Costco. We can now order with your voice. You can say, hey, Google, I'm going to turn this off because it's going to buy something. Hey, Google, buy a pair of sneakers, or buy Adidas's latest sneakers, and off it will go. And it's interesting because it's kind of gone back to that human interaction. We like talking. What is it, 50% of interactions with voice? But whether you have one of these or not, whether you use Siri or you don't, this is this idea that we are going to be speaking to machines. And actually, how does it work? If you have one of these devices, it's magic, right? And this is a favorite decoded quote. Any sufficiently advanced technology is indistinguishable from magic. So we live in a world of magic, but we find magic disempowering. If you don't know how the trick's done, you're just an audience participator. It's very disempowering. So what we're going to do for the next 14 minutes is go behind the screen of how things like voice work. In the old days, if you wanted to kind of like speak to something, a machine, there'd be a human listening and they transcribe. This is now fully automated. Like, how does Siri work? How do all these things work? How do you take a human voice and extract ones and zeros from it? Well, it works as follows. Basic physics. My background's in physics. I'm self-identify as an engineer. This is a snapshot of a violin. When you play a violin, the bow vibrates. And those vibrations you can see on the far right. Actually move air molecules. So as I'm speaking to you, the speakers, everything is air moving towards your ears. When the air hits your ears, your brain translates that into sound. It's kind of amazing. But how on earth does a machine do all of that? You make a sound, it moves through the air, and it hits some sort of microphone. So this is a close-up of an iPhone microphone. It's a very sophisticated microphone. Tiny, tiny thing. And what you can see, the little circles, these are columns which move as the air hits them. And as they move, they create an electrical signal, and that signal is captured as ones and zeros. So what a computer will do will detect motion in air, convert that into code, into binary. This is what a computer sees. But how on earth do you extract meaning from that? How on earth do you extract what somebody wants to do? Well, a couple of things happen. That binary gets converted into this. This is a waveform. Any musicians will be familiar. So you're looking at time along the bottom and then amplitude or noise along the top. This is a noisy signal. What you can do is actually analyze this data by looking at what are called the frequency components. So now you have time, you have frequency, and then color is representing amplitude. So you can kind of see like low notes, high notes. This is called a spectrogram, and it underpins every single speech-to-text algorithm that's out there. So this is what a computer sees. And again, we can demonstrate that. This is going to be an interesting experiment. This is another great tool. As I'm speaking, it's listening to my voice. Right? You can kind of get the idea. I'm going to try and go low. I can go high. I can't get that high. This is sound. This is what it is. And if you're interested, you can also listen to animals. They are communicating. They are this is what a bird sounds like. We're going to soon understand animals. It's going to be amazing. We're not there yet. But sound are these kind of spectrograms. And again, how on earth does the computer extract text from color? How does that work? Well, the last kind of buzzy word for today is this idea of neural networks. So if you try and program a machine using traditional techniques, it's very difficult. So researchers were inspired by human or animal brains, actually. And they said, well, animals are great at understanding sounds. Can we mimic them? What we're going to see is a short clip which inspired many, many researchers, which is of a man called Daniel Kish, who is blind. This is Daniel, and we're just going to watch how he has able to navigate the world.
I am a man who uses the techniques of a bat to navigate. And I have no recollection of ever having seen. So we have a structure here that has a roof, a pavilion. I got my first bicycle when I was 6. Go hiking alone in places I don't know. I've traveled to nearly 40 countries. I learned at a very early age that when I click my tongue, I get feedback from the environment all around me. It does not have the degree of definition that is available to vision, but it does have contour, it does have dimension, size, positions of things, layouts of things, and it also has information about texture and density.
So that's just the power of the human brain. You could literally retrain your brain to see using sound. And what researchers discovered is animal brains are very plastic. They're able to learn different things very flexibly, unlike this rigid way a computer does. So this kind of inspired this idea of a neural network. So this is this is the most complex slide I'm going to show. In fact, there's 2 more. The idea of a neural network is, again, OK, can we try and mimic how an animal brain works, which is you have little neurons or nodes interconnected, and each node specializes in detecting a certain feature. Okay? So the key here is this has to be a supervised system. Humans have to give it examples. It then learns, and then it can actually run on unknown data. So let's start with an example. This is me saying hello. That's what it looks like to a computer. And the way this neural net will work is the first thing it will do is we'll chop it up into sort of half-a-second fragments, or even smaller. It will then randomly choose a bunch of numbers. These numbers are random. They're the weights of each of the lines that connects the neurons. And based on those numbers, it will predict what that word was. Now, because it was random, it's terrible. It doesn't work. And this is the key to learning. Because we know it should say apple, it's going to compare each letter and calculate like an error. And then it's going to say, try again, minimize that error. So, different weights, hotel, getting closer. Change the weights again a little bit. Help, so it's really close, just one character off. And then the final answer is hello. So it's literally just numbers. AI is this scary thing. It's math. It's like matrix math. It's just numbers which are multiplied. So if you can convert data into numbers, you can send them through this kind of network, and then it will output another number. It's all numbers. So I find that reassuring. When I first started looking into this, I was like, I'll never understand it. Because it's just a bunch of numbers. So that's how you train a neural network. Then with unknown data, you send it through the network, and it will tell you, chop, 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 I think this is world. Okay, that's how all of these things work. Now, is anyone feeling a little bit overwhelmed and confused? Does anyone want to go home and start programming neural networks? It's really, really hard, but the great news is loads and loads of other people and companies have been building neural networks, supervised machine learning systems we can use. And they're accessible to us through APIs. Some people familiar with APIs? APIs, application programming interfaces. They're simply ways of connecting. So MasterCard has a bunch of APIs for like MasterPass and like fraud scoring and identity check mobile. We can actually use IBM's APIs. So this is IBM Watson. They have got a ton of different, very specific machine learning algorithms. So for example, I'm going to try this, speech to text. I'm going to have to plug in my microphone. So what's interesting is this system wasn't trained for people standing on a stage speaking. It's confused. So I have to plug in my microphone, because that's what it was trained to do. So these are the limitations. In order for you to see this, I'm going to try and zoom in. They are very racist. I'm going to have to choose an English accent because I'm a little bit, it won't understand me if I'm American. So then I'm going to start talking in a second, and then I'm going to zoom in and see what the text is. No idea if this is going to work very well. Hello. This is a test of IBM Watson's speech recognition in a very noisy, echoey environment. And what it's doing is taking my voice, sending it to the internet, chopping it up, running it through a neural network, and guessing what I'm saying. What do you think? Good? Bad? Not too bad. That's Watson. So good job, Watson. You can kind of see, but all of the magic is happening behind the scenes based on their data science. So that's how speech recognition works. Siri does the same thing, Google Home, they all do the same thing. So actually, if you as a business want to automate people transcribing, or you want to automate something, you can try this. It might not be the right answer for you, but there's nothing to stop you trying it. Google Watson APIs. You will find them, you can play with them, you sign up. It's incredibly easy. OK, the next type of, oh, no thanks, I'm not going to chat with an IBM representative. OK, this is Google Cloud's cognitive services. Inject AI into your business. Again, same idea. This time I'm going to show you something different. This is taking neural nets, but instead of sound, I'm going to look at sort of images. So I've actually got an image of a mystery object. Does anyone know what this is? Some sort of rock. I mean, it's just a rock. So I'm going to like drop it in here, and it's going to crunch the numbers. OK, so that's quite impressive. It's actually detected it's Everest. So not only is it a rock, it's a mountain, it's a geological phenomenon, there's sky, and it's all probability-based. Because remember, it's just trying to guess what is this closest to. But then Google does some cool things, and apparently it's the Khumbu Glacier. Crazy. So again, they've already done the really hard work of labeling and classifying and training. You can use these algorithms right now, just as I'm doing. The final one, in the few minutes we have left, is Microsoft. They have cognitive services. They learned a few lessons from Tay. One that I quite like, let's have a look, is, Preview. OK, so an emotion API. Can a machine detect emotion? Really important question. This is Microsoft's attempt. So what you do is you give it an image. Here's a cute kid. It then gives it some very mathematical scores. Anger, contempt, disgust, fear, happiness, neutral, sadness, surprise. You've got to watch out. That's 10 to the minus 6. It's very mathematical. But essentially, the most likely response is surprise. That's how this works. Again, they've had to train it on millions of images. So could be useful. Emotions. How could you think about using that in your products in helping bring a bit more humanity into automation? There are many, many other APIs for cognitive services out there, but they're all based on something like this. There are non-neural network models. There are many different models out there. As we kind of get towards lunch, these were the APIs, I do want to flag a question. How does it make you feel? How does AI make you feel? Now, I wouldn't be on here unless we're doing some sort of interaction. So rather than ask you individually, I'm going to use Microsoft's Emotion API, okay, to, in real time, get your emotion right now. This may not work, so we're going to see. Hands up if you have an iPhone. OK, please, on your iPhone, open Safari. Do not use Chrome. It's only going to work in Safari. You are going to also need iOS 11. If you don't have it, you can use a neighbor's phone. Hands up if you have an Android. Great. Please open up Chrome, Google Chrome. Are there any BlackBerry users in the room? It's not going to work on BlackBerry. Not going to work on BlackBerry. What I'm going to ask you to do in a second is visit a page, and when you're on there, it's going to basically ask you to take a selfie. If you don't see a selfie, it might not work on your device. Try someone else's device. Once you do that, here's the link. I'm going to visualize all of your emotions. So, on Safari, on your iPhone, go to decd.co.com/mc.ai. On your Android, go to Chrome. And what we're going to do is, as you take selfies, oh, there we go. We've got some selfies coming up. It's going to classify, using Microsoft's Emotion AI, whether you're happy, sad, or anything. So remember, how do you feel about AI? OK, all right, it's starting to happen now. Oh my goodness, it's going crazy. OK, perfect. So what we can do, wow, so you're either really happy or neutral. There are a couple of interesting faces here. Oh, that one's going a bit crazy. Only one person's terrified, and that's me. Wow, this is like flying. There are a couple of people, oh dear, somebody's not happy at all there. Wow, this has worked much better than I anticipated. A few people are like, meh, whatever. So that's cool. This is a safe space. Lots of neutral. So actually, these emotion AIs, oh, there's Gilberto, looking neutral. I don't think you look less neutral. I think you have an opinion about this. Let's have a look. OK, amazing. So this is slowly grinding to a halt as we look at this. But that took me about 2 hours of coding using Microsoft's Emotion AI. Now, is that useful? Actually, I can now go away and check who was really excited about this. And maybe I can say, let's explore AI further. If you're neutral or angry, I might say, you know what? Here's some amazing reasons why you should be excited about it. I just learned from Amy, actually, that I could also detect people's gender specificity if I wanted to. But I'm not going to do that. That is not ethical, not going to happen. But we now have this amazing data set of lots of data, almost too much data. This is great. So this is literally how accessible machine learning algorithms are to you all today. You can, in minutes, get a coder, get a data scientist, experiment. This was a huge experiment for us to measure emotion. Normally, this chap looks a bit meh. There we go. I think I know who that is. Oh, look at all these vomit faces. Just one vomit face. OK. Congratulations. That is a really difficult face to pull. Microsoft finds it really difficult. That gentleman looks quite terrified. There we go. So there are quite a lot of terrified. Oh, look, lots of. OK, very interesting. I think that might be neutral. There's a huge bubble of neutral. So it is here. But what we're going to wrap on, because I'm running a minute over, is generalized AI is far away. We're not going to be taken over by robots. It's too difficult. Specialized AI is here to stay. That's what Amy calls artificial narrow intelligence. Very specific AI tasks, like detecting emotion, like checking if it's a fraud or not. They're here already. We're living with it. And this is the last example I want to show you, which is one of my favorite, probably the only artificial intelligence products that I use that I actually think is the real deal. This is an AI assistant. And the idea is, it's really boring to have to respond to emails and say, hey, when do you want to meet? So Amy and Andrew Ingram are essentially an email address. You sign up, and you say when you want to meet most often, et cetera, and it has your calendar. So when you get an email saying, hey, it was great to meet during MasterCard Innovation Forum. Let's find a coffee sometime. You're like, OK, but I can only do before 2. And then they're like, oh, what about next week? And you're like, this is such a pain. Why am I wasting my amazing human ability? So what you do is you say, cool, yeah, Amy or Andrew. It is a shame they chose a female voice initially, then they added Andrew. Amy, sure, can you find 30 minutes? Then Amy or Andrew, without you on the emails, will do the email tag with the other person. So they will send the person, hey, they can meet here. I can't. You don't see any of this, because it's just a human working with this like AI email thing. And then, cool, once they agree, I'll send a calendar invite, and then Amy will just put it in your calendar. Honestly, it's like magic. These guys are based in Wall Street, New York. They're a great team. And I think what's really interesting about this is it's really hard to do this well. It sounds like it's simple, but it's very, very, very difficult to teach a machine to understand what you mean by 30 minutes next week. Like when? What day? And they're trying really, really hard, but they're only ever going to focus on this. They're not going to try and do everything else. So this is one example. I think it's the only one of actual real like AI products in for kind of human interactions. But we're going to see more and more and more of this. So on that note, I'm going to finish. Hopefully you've been enlightened a little bit. Machine learning is here to stay. Thank you very much. Have a great afternoon, and thank you. Great.
I'm gonna break through.
Ladies and gentlemen, this concludes our session for today.